Hello students, I'm Dr. P. Madhusudhan, working as Associate Professor of Chemistry in the Department of BSNH, Viviraju Institute of Technology, Narsapur. Today I'm going to discuss with you polymers. In the polymers chapter, I'm going to cover the following topics. Polymer, the classification of polymer, classification of polymers. Two, types of polymerization. Types of polymerization. In the syllabus, you have only to addition and condensation. Condensation polymerization. Okay. Next, plastics. Plastics are two types: thermoplastics and thermosetting resins. And under these thermoplastics, we are going to discuss preparation properties and uses of PVC, Teflon, and the thermosetting resins, bakelite, and another very important synthetic fiber, polyester. Preparation properties in polyester. So under thermoplastics, in the syllabus here, preparation properties and uses of PVC, Teflon, nylon 66. Thermosetting resins, in the syllabus here, bakelite preparation properties and uses. Another very important synthetic fiber that we are going to discuss, polyester. Next topic, natural rubber. Synthetic rubbers, conducting polymers, biopolymers. These are the topics we are going to discuss in this unit. So before discussing these topics, you need to explore, you need to check your previous course knowledge. So under prerequisites. So under prerequisites, please pose question yourself. One, what is polymer? What is polymer? What is the difference between? What is the difference between polymer and plastic? Two, you need to check how to write structure organic compound. Unless you don't write structure of organic compound, it will be difficult to study polymers. Okay, so you need to check your previous course knowledge. Already you learned in intermediate how to write organic compound structure, how to write structure of organic compound, right? First one, what is the polymer? So polymer is a lengthy, bulky unit formed by the combination of three or more than three monomeric units. This is called polymer. All creatures, all living organisms, all dead remains of plants and animals are made up of polymer only, excluding skeletal structure, remaining part, flesh created in the nature, made up of polymer only. So polymer is a common, lengthy, bulky product formed by the combination of three or more than three monomeric units, smaller units, right? So another important question: difference between the polymer and plastic. So polymer. So the plastics, polymer. Just now I explained the nature that is visible to you, excluding skeletal structure, all living organisms, excluding skeletal structure, teeth, body of all living organisms, body of plant, a tree, all are made up of polymers. The plastics, difference between plastic and polymer. Plastics are the articles of desired shape. So we obtain articles of desired shape like pen, mug, cup, bucket that we use for domestic purposes. All are called plastics. The components, the fabric, the articles of desired shape uh, can be derived from polymers during the process of molding. During the process of fabrication or molding, we obtain articles of desired shape. So these articles of desired shape are called plastics. So example that we use for domestic purpose. All without plastic, we can it will be difficult. Without we need plastic materials, maybe bucket, pen, all are made up of TV cabinets. These all are made up of plastics only. So all plastics are polymers, but all polymers are not plastics. Right. Next classification. Right. Classification. All polymers are classified based on their skeletal structure and functional groups attached. Skeletal structure classification made based on skeletal structure and groups may be substituent or functional attached. First one, homolinear. Homo. This polymer is made up of identical units, identical monomers, known as homolinear and straight chain. Homolinear polymer. It is called homolinear polymer. If the polymer this polymer consists of main chain as well as branch and with identical groups, identical monomers. It is now it is called homo-branched polymer. Next, copolymer. Copolymer. Like above, homolinear per straight chain 2. Homo consisting of identical atom. The polymer which is made identical atom. It is called homopolymer. Homopolymer two types: homolinear, homo-branched. If it is polymer is straight linear consisting of identical monomers, is called homolinear polymer. If the polymer consisting of branch as well as main chain, and it is both branch and main chain made up of identical monomers, then it is called homo-branched. So next, the polymer which is made to different monomerics is known as copolymer. Same copolymer further divided like homopolymer two types: collinear polymer, linear polymer, co-branched. Collinear polymer. this chain consisting of this polymeric chain, this polymer consisting of two different monomers, composed of two different monomers, and it is called collinear polymer. Collinear polymer. Let me write clearly. Collinear polymer. Next is the polymer consisting of branches. This co-branched polymer consisting of two different monomers, both on main chain as well as branch. So known as co-branched polymer. Graft polymer. What is the difference between graft polymer and co-branched polymer? In co-branched polymer, main chain consists M1, M2, M1, M2 monomers. Main chain composed of M1, M2, M1, M2. And on branch also made up of two different monomers. When you come to graft polymer, this monomers attached on branch different from monomers on main chain. This polymer is known as graft polymer. The last one, tactic polymer. So I will do one example. Keeping that example, writing that example structure of that organic compound, I will explain about tactic polymer. Also called tacticity. The organic compound, the polymer which exhibit this character is known as tacticity. So C8. I will give one compound, one polymer. Three types of polymers are there. Skeletal structure of first one, skeletal structure of second one, skeletal structure of third one, so all three different, having same mark, all three. Their skeletal structure is different, keeping based on functional groups attached, can be classified into three types. So all are having same molecular formula. 1, 9 carbons, hydrogens 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, S16, 2, 3, 4. Functional groups 4. X maybe fluorine, chlorine, bromine, iodine. All three are having same formula, same molecular weight, but exhibit different physical chemical properties due to difference in the X atoms, functional groups attached to the main chain. The first polymer is called isotactic, syndiotactic, tactic. Isotactic polymer. Tacticity. What is tacticity? Let me define. So all are three having same molecular formula, same molecular weight, same functional groups attached to the main chain, but exhibit different physical chemical properties due to difference in the arrangement of functional groups attached with respect to main chain. This specific characteristic, because of difference in the arrangement of X atoms attached to main chain, known as tacticity. The polymers which exhibit this tacticity, known as tactic polymers. Tactic polymers are three types, classified based on their attachment of functional attachment of functional groups with respect to main chain. X atoms are main side with respect to main chain. It is called syndiotactic. If the X atoms are arranged alternately, here this side, next after one methylene X, after this one, then it's called isotactic. If X atoms are at random with respect to main chain, known as atactic. So arrangement of tactic polymers classified based on the arrangement of exact functional groups attached to the main chain. If the exatoms are same side with respect to a main chain, it is called symdiatactic, not isotactic. Next, if the exatoms or any functional attached to the main chain alternatively, this side, next this side, next this side, next this side, right? So alternatively, then it's called isotactic. Isotactic. If the exatoms or any functional groups, other functional groups attached to the main chain are at random, year, next year, random, irregular, known as atactic. So let me explain clearly about the polymer. So definition. N number of polymers subjected to compressed in a closed container. N number, N may be maybe 6, 12, 18, 36, 46, 10 lakhs, 20 lakhs, 1 lakh, N number. In a closed container, they combine each other. Link each other. Formation of a lengthy, a bulky unit takes place. This lengthy bulky unit is called polymer. The reactants, the smaller units which are involved in linking, this can be happened under the conditions of high pressure and temperature. High pressure, closed container, pass the n number of smaller units into closed container, compress them. When you compress them, they come closer. Van der Waals attractions increases. They combine each other, they connect each other, they link each other because each carbon is having one lone electron. If you want more explanation on this, you can write skeletal structure for this. Just above room temperature. Each carbon, no more pz electron exists, no more pi bond. Each carbon consisting of one electron. Each monomer consisting of two lone electrons capable of linking, forming two bonds. These two bonds, new bond. I will put new link, new bond. It's a bifunctional in nature. Having each carbon monomer consisting of two carbons, each carbon having one lone electron just above room temperature. Above room temperature. At room temperature, we imagine that some attraction exists between pz electron. It is called pi bond. We give it one name is there. So really it is not original, it is not bond. Some attraction prevails because on this carbon lone electron rotates clockwise, in this carbon lone electron rotates anti-clockwise. Some attraction prevails there. So that attraction, we have given name for that attraction. It's a pi attraction, pi overlapping. Actually, it is not pi bond, right? So above room temperature, each carbon consists one lone electron capable. N number are there. This links with another monomer. This lone electron pairs with another monomer. N number are there. They combine each other because monomer consisting of two electrons, it can form two links, two bonds with another monomer. So chain length may be 10 lakhs, 20 lakhs, 1 crore like this. So it's bifunctional in nature. It is capable of forming two bonds, bifunctional in nature, right? So this lengthy, bulky product formed by the combination of smaller units. This bulky, lengthy product is called polymer. The smaller units which are involved in linking, known as monomers. Converting monomers into polymer, known as polymerization. So repeated units in the polymeric chain, known as degree of polymerization. These are the terms we need to define in this unit. Polymer is a lengthy, bulky product formed by the combination of smaller units under the conditions of high pressure, known as polymer. The reactants, the smaller units which are involved in linking in polymerization, known as monomers. The process of converting monomers into polymer is known as polymerization. Repeated units in polymeric chain, known as degree of polymerization. So we'll discuss in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.